The following content is created by DrAvitech. Your support and donation will help me continue to offer high-quality educational resources for free. To make a donation, send an email to 6drcyril@gmail.com or comment donations below. Welcome guys. In this video, we're going to solve this question. I'm DrAvitech, and on my channel we deal with mathematics and engineering problems. So let's get started. Hit the subscribe button, relax, and understand Fourier series. Now for this, we have this function. You're not going to graph it. It's completely useless because this can never be even or odd. So there are two different functions, so you don't really want to do that. So what you want to do is you want to start finding your Fourier series coefficients immediately. So there are three coefficients you have to find: a naught, a sub n, and b sub n. Now the period is 2 pi, as we can see. From 0 to 2 pi is 2 pi, so the period is 2 pi. So we're going to say this is a naught. A naught is 1 over pi integral from 0 to 2 pi, because that's our limit, 0 to 2 pi of f of x dx. That's what we're going to be getting. This is what we're going to be getting. So this will become 1 over pi. Now, there is no single function value from 0 to 2 pi. There's no value from 0 to 2 pi. Instead, we have 0 to pi and pi to 2 pi. So we're going to separate it. So I'm going to say this is integral from 0 to pi and then plus integral from pi to 2 pi. We're going to separate it. We have to separate it. All right. Now the f of x value, when it's from 0 to pi, f of x value from 0 to pi was 1. So this will be 1 dx. Then next, f of x value from pi to 2 pi is 2 dx. All right. Now the next thing I'm going to do is I'm going to say, let's integrate 1. I think this will be giving us something like, it looks like, let's see. Sorry, this will be 1 over pi. Then, if you integrate 1, you basically get x. So this is x from 0 to pi plus, now the 2 is a constant. So if you integrate 2, you just get 2x. So this will be 2x from pi to 2 pi. Now this will become 1 over pi. Now here, anywhere you see x, you're basically going to put pi and 0. So this will be pi minus 0. That's what it will be. Plus 2 into, anywhere you see x here, you put 2 pi and pi. So this will be 2 pi minus pi. The upper and the lower limits, you need to do them like that. So this will become 1 over pi. Then we have pi plus, because pi minus 0 is pi. Now 2 pi minus pi is just pi. You know, this is like saying that this is 1 pi. So 2 pi minus 1 pi is 1 pi. 1 pi times 2 is 2 pi. In fact, I was like, this will give you 3. So this is 1 over pi. Pi plus 2 pi is 3 pi. So this is 3 pi. Now when pi cancels out pi, this will be giving you 3. So I was kind of correct. So that will be giving us 3. Next coefficient to find is a sub n. So a sub n is 1 over pi integral from 0 to 2 pi of f of s cos nx dx. Now again, we're going to be splitting this the way we did here. We're going to say this plus this. So this will become 1 over pi integral from 0 to pi plus integral from pi to 2 pi. Now what is the f of s value from 0 to pi? From 0 to pi, f of s value was 1. So this will be 1 cos nx dx. Then here, this will be 2 cos nx dx. Okay, let's make this much more beautiful. So right now, this will become 1 over pi. Now, if you integrate cos, because the 1, it's not really relevant. 1 times cos is still cos. So if you integrate cosine, you will get sine. So this is sine nx over, you must differentiate the nx with respect to x, you will get n. So you divide by that very n. And this is from 0 to pi. Plus, Now this 2 here, I don't really think it's a problem. So this is 2. Now integrate cos, you will have the same sine nx all over n. And this is from pi to 2 pi. All right. Now, ladies and gentlemen, this will be giving us 0. Why would this be giving us 0? Because sine, when you put the value of pi here, sine n pi is 0. It's a special value. Sine n pi is 0. Next, when you put 2 pi, n times 2 pi is 2n pi. Sine 2n pi is still 0. And then sine 0 is also 0. So if this is 0, this is 0. That means every single thing for a sub n is 0. That's the meaning. Because 0 times what's outside will give us 0. So a sub n is gone. Now let's find b sub n. So b sub n is 1 over pi integral from 0 to 2 pi of f of x sine nx dx. So that's what b sub n is. So this will be 1 over pi integral from 0 to pi of 1 sine nx dx plus integral from pi to 2 pi of 2 sine nx dx. Just basically the same thing, but this time around it is sine. It is sine. That is, instead of cosine, we now have sine. Now let's repeat the same thing. This will be 1 over pi. If you integrate sine, you will get minus cosine. So this is minus cos nx over n. The limit here is 0 to pi. Then plus, this is 2. This is 2. So this is 2. If you integrate this sign, you will get minus cos nx over n. And this is from pi to 2 pi. Okay, this is getting interesting and beautiful. So right now, this minus is a constant. I can bring it out because there's minus here, there's minus. So I can bring out this minus. There's n here, there's n here. So n is common between the two. Minus is common between the two, so I can bring them out. So this will become minus 1 over 2 pi, because the minus is coming from the numerator. Sorry. Then n pi. Then n is coming from the denominator to meet pi. Then what we have left to become cos nx from 0 to pi plus 2 cos nx from pi to 2 pi. Remember to hit the subscribe button, like this video, share across to your classmates, and leave a beautiful comment. So let's proceed. So let's put in our limits. This will be minus 1 over n pi. Then anywhere we see s, we're going to be putting pi and 0. So this will be cosine of n pi, because this is x, so put in your pi, that's n pi, minus, put in 0, this will just be cos 0, because n times 0 is 0. So this is for this part. Plus 2, you can put a bracket if you wish, plus 2. Then we're going to say this is cos. Now this is n. If your s is 2 pi, n times 2 pi is 2n pi minus cosine n times pi is n pi. All right. So this is minus 1 over n pi. So we're going to be having cosine of n pi has a special value. And that special value is minus 1 to the power of n. And then minus, cos 0 has a special value, that special value is 1. Okay, plus 2 into cosine of 2n pi has a special value, that special value is 1 also, minus cos of n pi is minus 1 to the power of n, special value 2. All right. So this will equal minus 1 over n pi into, now I want to leave this part like this, minus 1 to the power of n minus 1 plus, now use 2 to multiply. 2 times 1 is 2, 2 times this will give us minus 2 into minus 1 to the power of n. That's what it will give to us. So we're kind of opening the bracket. 2 times 1, 2. 2 times minus this will give us minus 2 into this. So it's easy. Now, let us see. This is minus 1 over n pi. Now, minus 1 plus 2, or 2 minus 1 is 1. Yeah. Minus 1 plus 2, or 2 minus 1 is 1. So you write that down. Now, this and this are kind of similar. So this is 1 here. So imagine if this were to be x. So we have 1x minus 2x. That's just minus x. So this is minus 1 to the power of n. That's what it's going to simplify to. That's what it's going to simplify to. So that's what it's going to simplify to. Beautiful, right? Now, this bracket has a particular value. This bracket has a particular value. So we're going to say when n is odd, let's see what it's going to look like when n is odd. So this is 1 minus into minus 1 to the power of n. So this is 1 minus. Now, if we're going to pick an odd value, let's say to the power of 1, because 1 is odd. So this is 1 minus minus 1, because anything raised to the power of 1 is that same thing. So this is 1 minus minus is plus. And then, sorry, plus 1. And then this will be 2. So this will become the value of this bracket when it is odd. Now this then tells me that my b sub n will then become minus 1 over n pi times what this bracket gives to me. Now this bracket gave me 2. So that means b sub n is minus 2 over n pi, provided n is odd. Now, what would it be when n is even? So when n is even, the bracket is minus 1 minus 1 to the power of n. So this is 1 minus minus 1. The n value, let's say 2. Let's use square. So this is 1 minus 1 squared is plus 1. And then this will be 1 minus 1. So this is 0. Now imagine if this is to be 0. Imagine if this is to be 0. That means that my b sub n, which was here, so b sub n is minus 1 over n pi times whatever bracket I have. So this bracket here is giving me 0 for all even values. So this will just be 0, provided n is even. Now let me put on my answers here because I'm going to wipe the board. So let me put my answer here. So a naught is equal to 3. It's equal to 3. A sub n is 0. Then b sub n is minus 2 over n pi, where n is odd. And then is 0 otherwise. So let me wipe the board. So we find the Fourier series expansion. So f of x is equal a naught over 2 plus the sum from n equal to 1 to infinity of a sub n cos nx plus the sum from n equal to 1 to infinity of b sub n sine nx. Alright, so we know this is 0, so this guy is gone. So this will be f of x equal a naught is 3. A naught is 3. So this will be 3 over 2 plus the sum from n equal to 1 to infinity. Now b sub n is this. So this is minus 2 over n pi sine nx. But always remember that n must be odd. Yep. But you shouldn't be putting this, yeah. But no problem. So this is 3 over 2. Now the minus 2 over pi is a constant here. So bring it out. So this is minus 2 over pi. And then the sum from n equal to 1, where n must be odd, to infinity. If the minus 2 is out because it's a constant, the pi is also out. What we left is 1 over this n sine nx. That's what's going to be left. That's what we're going to have. That's what we're going to have. What kind of language is that? Okay, So anywhere I see n, I'm going to be putting the numbers. I'm going to be putting some numbers. So this is 3 over 2 minus 2 over pi. Now let me start with n equal to 1. So if n is 1, this will just be 1 over 1 sine 1x. So which is basically sine x. Then next will be 3. You know I did not say 2 because 2 is not odd. So let's go to 3. So this will be 1 over 3 sine 3x plus 1 over 5 sine 5x plus 1 over 7 sine 7x. And just like that. Just like that. So this is f of x. This is f of x. Now remember that you can make this function if the equation says this is the final answer. If they say find the expansion. If the equation says leave your answer in terms of n, I always do that. So what is going to be is if they say leave your answer in terms of n, replace n with 2n minus 1. So when we do that, that means we're going to be having f of x equals 3 over 2 minus 2 over pi. The sum from n equal to 1 to infinity. This will now become 1 over 2n minus 1 sine 2n minus 1x. And this will then become the answer to the Fourier series. And with this, we're going to end this very question. This is the solution. Remember to hit the subscribe button, like this video, and I'll see you next time.